Hi everyone, welcome back. Today we're doing shuffle strings. So for this question, we're given a string S and an integer array indices of the same length. The strings will be shuffled such that the character would move to the position I. So if that was not clear, we are moving C to index 4 in the shuffle string, O to index 5, D to index 6, so on and so forth, and we get a string like this. So this is pretty much the shuffling. So in this case, the test cases are pretty similar, so I would skip this. We pretty much went through that with the explanation. For the second example, in this case, the string contains A, B, C, and the corresponding index for A, B, C is 0, 1, 2, which is in order. So what this means is that the S is already shuffled. So in this case, we will just return back S. So if we represent the length of S and the length of indices to be n, and n ranges from 1 to 100, then in this case it means that we have up to 100 characters and we have at least one character inside each of our test cases. S will consist of only lowercase English letters, thank goodness, and every single index inside this indices array would range from 0 to less than n, understandably because they are all indexes. And similarly, since indexes are unique, all values of indices are unique. So to solve this question, we'll be creating a shell character array, and we're using a character array here instead of a string. In case you're wondering, it's because in Java, strings are immutable. So if you want to change a character inside a string, the string actually remakes a copy that contains that change. So to prevent that, we're using a character array which is mutable. It allows us to change a character in all one time. So we're using a character array in this case. And afterwards, we will iterate through index from 0 to length of indices. And using this index, we will get the corresponding character in S as well as the shuffled string index where this character should be after shuffling. And we would update the shell character array by setting the current character to be at this index. So that was a lot of words, so let's get started. So first we will define the shell, the shuffled string shell. This will be storing all the strings in the right position. So let's define a character array and let's call this shuffled string, and this will be equals to a new char array over here, and it will take in the length of indices. So this is pretty much a character array of fixed size, and we initialize it to have enough memory to store indices length characters. So once we're done, we will iterate through index from 0 to just before the length of indices. So we will start off with index equals to 0, and the for loop will run as long as the index is less than indices length. And after every iteration, we will increment index by 1. And using this index, we will get the current string, current character. This will be equals to S charAt index. So for our viewers who are new to Java, this string over here, S over here, is really an object. And objects, like you might know, objects contain methods. So in this case, this charAt is a standard method that allows us to get a character at a specific index inside a string. So using this current character, let's also get the corresponding char index. So this will be indices at index over here. And the last step would be to update shuffled string to put this current character at this specific index. And that's pretty much the approach. And once we're done, we will recreate a string by passing in shuffled string like this. And that's pretty much it. So to be sure that this approach works, let's copy the test case that's given to us and try tracing out this approach using this test case. So this is a tedious process, but this is a very reliable way to check that our approach works. So let's first define shuffled string. Let's shrink this so that we have more space for tracing. So shuffled string equals to a character array of size 8, where every single position contains noun. So 4, 5, 6, 7, 8. So we have an array right here. Let's start off with index 0. So using index 0, we can see that the current character we have is L. the character index is 4, and we will be updating 0, 1, 2, 3, 4 with L. Let's move on to index 1. Now we see... Sorry, actually this is supposed to be 4, right? Sorry, this is supposed to be C, not L. Sorry, I made a mistake there. But let's move on to index 1. Current character will be O. This is index 5. So let's put O at index 5 inside shuffled string. Let's move on. Now we see D. D is 6. So let's put D at index 6. Now we have index 3. Now we have E. And E is index 7. So let's put E here. Index 4 in this case is L. So this is sorry, did I? Yeah, index 4. So this is also index 4. So let's, no, sorry, it's index 0, right? Yes, it's index 0. Sorry for the confusion there, but you get the idea. Index 5 is equals to the character E, and the index is 2. So let's put E at index 2. Index 6, that's also an E, but the index is 1. So let's put E at index 1, and finally, this is the final character in S. So this is pointing to T, and T is going to be moving to index 3. So let's put T here. So we get Leetcode, and if we pass this character array into a string, then we will get Leetcode. So I made some mistakes as I was tracing, but I hope that it's clear what this approach would look like when you execute this under the hood. So let's run this passes, and let's submit this. So that's pretty much it. Looks like it passes, thank goodness. So let's discuss the time complexity of this approach. So in this case, if we let n to be the number of characters in S or indices, they both have the same length. So we can see that we'll have a time complexity of O(n) here for the for loop, because we are iterating from 0 to the index just before indices. So this will scale linearly with the size of the number of characters in S. And the second thing is, for each of these steps over here, they're each at O1 time. Each of them have a time complexity of O1. So getting a character from a string is O1. Getting an integer from an array of integers is also O1. And setting a character to this index in an array of characters is also O1. So in this case, every single iteration is O1 time. But in this case, when you want to recreate the shuffled string into a string, understandably in the strings constructor, you will need to iterate through every single character in the shuffled string. So this is also going to be O(n). But since it's O2n, if we remove the coefficients, it's going to give us O(n) time. For the space complexity, we are initializing a character array of the same size as S or indices, so in this case it's going to be O(n). Each of these operations over here, like specifically these two, would take up O1 space, and we are reusing the same character and integer, so pretty much O1. O1 for this temporary variable here as well, and we have returned a new string in this case as well. So a string is pretty much a copy of S. So this is also going to take O(n) space as well. So the space complexity is O2n, but if you remove the coefficients, it will just be O(n). And that's pretty much it for this question. I hope this was useful. I personally found this very useful for understanding the charArray method under strings, and also learning how to define an array of characters like this. So I hope this was useful, and I will see you in the next video.